Lab 3 was about the Black Hole Orbit Lab. The objective of this lab was to find the mass of a black hole given the initial position. A star orbiting the black hole's data was given, as well as its mass. The net force on the system was also calculated along with these using VPython. I found the mass of the black hole to be 4.039 times 10 to the 31st kilograms. The two main physics concepts involved are the momentum principle and Newton's law of universal gravitation. The momentum principle states that the net force is equal to the ratio of the change in momentum over the change in time. The law of universal gravitation states that the gravitational force is equal to the gravitational constant times the two masses over their distance squared. And this is when one body exerts a gravitational force on another in space. Also, the net force can be broken down into the parallel and perpendicular components. This equation seen here is used in my code in order to calculate the mass of the black hole, where it equals the magnitude of the net force times magnitude of the distance between the black hole and the star squared over the gravitational force times the mass of the star. In my code, here's the part where I put in the star mass, which is 4.7383 times 10 to the 27th kilograms, and the initial black hole's position. Delta T was 86,400 seconds, given as the length of one Earth day. The first while loop here calculates the x and y components of velocity, while the second while loop calculates the changes in momentum and net force, as well as the change in velocity. Here we can see Newton's second law applied where the net force in each direction is the parallel and perpendicular components of the change in momentum. My arrow scale is very small for better visualization. When my code is run, however, only this green curve shows up as it slowly runs. There may be something in my initializations that is an error in the code. And it makes this small trajectory. The curve should actually look like one big orbit around the center. So what does it mean? So the perpendicular net force and the change in momentum, and then the parallel net force and the change in momentum, and then the overall net force and the change in momentum, they're different in how they are arrived at. Even though these qualities are equal, these quantities are equal, and these quantities are equal, F net is found using the gravitational law shown before, and the change in momentum is found using the change in velocities, which can be seen here in my code, where the momentum equals the mass times the velocity for the initial and final values. So what if a different black hole was present in place of the old black hole, yet the motion of the observed star remains unchanged? We wouldn't be able to tell the difference between the new black hole's gravitational force because the gravitational force did not present any observable change to the star's position data. Therefore, we wouldn't be able to tell that it was a different black hole with a different mass.